All right, now we're going to start with reviewing some trig identities. Okay, and I know that you guys worked on these in geometry, so we should be able to go through them painlessly. Let's hope. Okay, we are well familiar with this identity, and all the identities are going to be highlighted, and all the identities that you're going to need to work with are going to be on the back cover of your textbook. So, and all of them here are going to be highlighted. Sine squared plus cosine squared equals 1. We know we got that. We derived that from the unit circle. Okay? That's an identity. Means, okay, for any value of x, degree value, radian value, this statement will hold true. Sine squared of pi over 6 plus cosine squared of pi over 6 is 1. Do not get confused. These are not equations. We are not solving for anything, okay? These are just well-known facts, okay, that have been proven and will be used as the basis for proving additional facts, okay? So that's why you saw a lot of it in geometry, because you did a lot of proofs in geometry, okay? Now, once a trig identity is established, it can be manipulated much like a equation, so that this identity, known as a Pythagorean identity, can be manipulated quite easily to say sine squared is 1 minus cosine squared. Cosine squared is 1 minus sine squared. And those are going to be the formats you're going to have to remember, because you're going to see them a lot, all right? It's nothing new. It's just manipulating that previous one. Now, okay, by further manipulating, we can come up with two other trig identities, which are, again, Pythagorean identities. It's implying that they are stemming from Pythagorean theorem. So I'm going to propose that we take our identity, our starting identity up here, sine squared plus cosine squared equals 1. Divide both sides by sine squared, okay? Again, in as much as it is an identity, it's an established true fact, we can manipulate it like an equation. We can do things to it on both sides, and we're going to forewarn you about that once we start proving identities, because you won't be able to do that. Okay, so having done that, okay, sine squared over sine squared is 1. Cosine over sine should be identified as the cotangent, okay? So, and 1 over the sine squared, it should be identified as a cosecant squared. So this is another popular identity, okay? And again, do you have to remember it? Yes, but you can always remember where it comes from, because you got the sine squared plus cosine squared and you divide it by 1. Another Pythagorean identity is going back to that original identity and dividing both sides by cosine squared, which would be tangent squared plus 1 equals secant squared. This is one that you'll learn, we will use a lot. We will use a lot back and forth, okay? So right now, our repertoire of identities is growing, okay? Now your book will also include some of the ones that are the more obvious, like the fact that we know that 1 over the sine is the cosecant, okay? These can be manipulated as well, okay? So in other words, come back here and you could say, well, okay, the secant squared minus the tangent squared is equal to 1. That's the same thing. It's just manipulating that, okay? Here are some other identities that we have seen, which we've given rise to based on the graphs, okay? The sine of a negative angle is the negative sine of the angle. And that was viewed because of, we saw that when we looked at the graph and looked at the symmetry about the origin. The cosine is symmetric about the y-axis, so the cosine of a negative angle is the sine of a negative angle, okay? And these things are jumping a little bit too fast. Now the tangent. Now we haven't even discussed a whole lot about tangent, but it naturally follows from this. Since tangent is the sine over cosine, work it out for yourself to show that the tangent of the negative angle is the sine of negative x over the cosine of negative x, which will become the negative sine of x over the cosine of x, which will collapse to the negative tan of x, okay? Now, these are the cofunction identities. We talked about them very early. The sine of one angle is the cosine of its complement. And the complements are read as pi over 2 minus x, pi over 2 minus x. So these are very handy identities that come in hand where you can put the cosine in terms of the sine or vice versa. Okay? And we also know the periodic nature of the trig functions, in which we have that the sine, if you shift the functions by their period, they will come back onto themselves. So sine of x plus 2 pi is the sine of x. Cosine of x plus 2 pi is cosine of x. And again, not having talked a whole lot about the tangent, but in as much as we see this identity, shifting the tangent by pi shifts it onto itself, which suggests that the period of the tangent is pi, not 2 pi like the sine and cosine. Okay? We have these identities which I'm going to hold off on for now. We should be able to work with the identities outlined on these two slides to get us through a bunch of examples, or which I will do next. Okay, so that'll get us started. All right, here we go. We're done.